Hello, everyone. Welcome to this presentation entitled ML-ERV, short for a machine learning-based CO2 emissions model designed for rental vehicles. My name is Aola Yousfi. I work for Carbooker as a data scientist, and I have a PhD in data science. I'm here to talk to you today about our project to calculate or to make predictions of CO2 emissions prior to using the vehicle. So, without any further ado, let me begin. Here is the agenda for this presentation. So, first, we're going to kick off with an introduction, then the literature review before I get to our model, the ML-ERV. Next, the evaluation, discussion, and results. Finally, I'm going to conclude this presentation and present future research directions. Okay, so the main objective of our project is to make predictions of CO2 emissions prior to using the vehicle. I'll give you an example. If you are a client, you go to our website and you fill in the form with your information and for instance your name, the rental period, the pickup station, the return station, your place of work, your home address, etc., all this information. And us, based on this information, we're going to make a prediction of CO2 emissions before you actually use the vehicle. So this is the idea here. Why is this important? Because of the growing focus on sustainability in the rental vehicle industry. So every car rental company needs to report its CO2 emissions and reduce it. Okay. Uh, while working on this project, many research questions were raised. For instance, how to accurately predict CO2 emissions from rental vehicles prior to using them. A second important question is to how to develop predictive models for CO2 emissions estimation and how to accurately identify key factors influencing CO2 emissions. Which brings me to the literature review. The researchers grouped CO2 calculators into four major categories: calculators that use mainly the distance, a second category that uses the vehicle type, a third category that uses fuel consumption, and a fourth category that uses the average vehicle speed. In this same section, I'm gonna present the limitations of these state-of-the-art approaches and why they are not enough for our study of our project. Okay, behold on this table, please. It summarizes the key factors used by each category of calculators. For instance, if we take the calculators using mainly the distance, so they mainly use the distance and vehicle type along with other factors. But since we only present in this table the common factors for calculators belonging to the same category, so we only kept the distance and vehicle as the most common factors in this category. Same thing for calculators based on vehicle type. Then we have calculators based on fuel consumption. They mainly use fuel type, fuel consumption. The fourth and final category that is based on the average speed. They mainly use fuel consumption, speed, and vehicle type. So why these calculators are not enough for us as a rental company? Because they were not initially designed for renting or for car rentals. As a result of that, they don't take necessarily into consideration some features that are unique to that industry. For instance, the exact distance during a period of time during the rental period. Also, they don't profile drivers. As you all know, the way you drive your car influence how much CO2 you're gonna release. So an aggressive driver when will have for sure will releases more CO2 than a gentle or a moderate driver. Also, they don't use precise information about the vehicle, such as the category, the type, transmission, etc. And they don't use the driver's place of work, its pickup station, return station, and it's his home address. So this is why we decided to develop our own model that faces all these challenges and that fits the unique requirements of the rental industry, the rental car industry. Now we're gonna move on to our model, so the ML-ERV. First, I'm gonna describe our data set, the data set we used to build our model. So we used the car bookers bookings data set, which at the time contained around 26,770 and a total of 114 variables. The percentage of missing values was about 15%, and the percentage of invalid records was about 32. Um, from all these variables, we only kept those that are more valuable for our project. So the table this table presents all the variables we kept. So we have the ICRIS code. I don't know if you are familiar with the term, but the ICRIS code is a code from 4 letters. And each letter refers to whether the category of the vehicle, its type, the fuel type, whether it's automatic or manual. So it kind of identifies the vehicle, and it's a it's a universal coding. We also use the mileage, the traveled kilometers. We use as well the period, the rental duration in half days, the included mileage, which refers to how much the driver can drive without incurring additional charges. We also use the home address of the driver, the address of his workplace, the pickup country, and the return country. Then we trained our data set on 4 different models: decision trees, random forest, Adabus, and XGBoost. Next, we're going to present the results we obtained for each one of these models. Okay, so we trained the data set on all these 4 models, and we divided the data into 80 for training, 20 for testing, and then 70 for training and 30 for testing. And we obtained better results with 80 to 20%. And as you can see, based on the metrics we used for we used RMSE, MAE, R squared, MAPE. So we obtained better results with the XGBoost model. Okay, let's conclude this presentation. So we first review the state-of-the-art CO2 emissions calculators before we showcase their key limitations in the rental vehicles industry. Then we introduced our model, ML-ERV, and showed why is our model more suitable for the rental vehicle industry more than the state-of-the-art approaches. Finally, we evaluated our model based on the metrics R squared, RMSE, MAE, and MAPE. And the results indicated that XGBoost has the best predictions. And you can go back to our paper to see all the details about the evaluation. We also compared the results obtained by our model to the results obtained by the state-of-the-art approaches, and we almost got better results than the state-of-the-art approaches. You can find all the details in our paper. As future directions, we intend to include more factors, for instance, the registration number, the vehicle model, and as well, as I said earlier, the driving style, which is very important in predicting CO2 emissions. Thank you, everyone. If you have any questions, I'm more than happy to answer them.